Hello everyone. Today I answer two questions about the stack and queue implementation using linked list. Well, implementation and stack using the linked list. When implementation and stack using a linked list, I need to remember that a stack following the last in, the last out LIFO principle, meaning that that's the last element add in this first one to remove. To achieve this is with the linked list, I use the head of the list as top and the stack. Each time push a new element, I insert it a new head. When copying the element, I update the head to the next node. Stack operation, for example, the push adding add element, create a new node, point its reference to current head, update the head to point this new node, pop in pop, removing element, checking the stack empty, move the head pointer to the next node, effectively removing the current head, get top, getting the top element, return the value and the head. Notice since the top and the stack always the first node is empty, checking the stack empty, simply checking if its head is null. The times complexity push O1, adding the node and head and take the constant time and pop 101, removing the node from the head and is also a constant time. Get O1, access the head node is the immediately operation. In if empty O1, checking if the head is null is constant time. All right. For the implementation, queues using the linked list, queues follow the principle first in first FIFO. Means that the first element is the first to remove. To implement the queues using the linked list, I need two pointer, front and rear. Pointer for front point for this element in the queue, and rather the point is element in the queue. All right, each time I enqueue add element and append the rear when I dequeue remove element, I remove from the front. Queue operations. Enqueue, adding an element of the rear, create a new node. If the list empty, both front and reader will point is known. Others way see the current rear will point to the new node and the rear is update. The queues remove an element from the front, checking if the queue is empty, move the front the pointer to the next node, remove a reference and previous from the node. If front become null, also set reader to null. Size, getting the numbers elements of the queue, traverses the list from to rear, counting the nodes. If empty, checking if the queue is empty, simply checking if the front is null. The times complexity for this part in queue O1, adding the rear is constant time because it's maintain the pointer to the rear. Decrease 101, remove it from the front and constant time because maintain the pointer to the front. And size using the ON, counting the nodes take a linear time when the M is the number of the elements. If empty, using the complex in this part is O1, checking if front is null is a constant time operation. In conclusion, using linked lists to implement a stack and queues have advantage as avoid to fix size limitation of arise and allows efficient memory using. However, a stack is easier to implement using linked lists since it only requires many to head, while queues needs both front and reader pointers to ensure the efficiency in queues and the queues operations. Okay, this is all my part for this presentation. Thank you for seeing my video.